node adapter, which will push the new information into the pod, but also the pod itself needs to be able to read this information and be able to refresh at the right time. So that's kind of where it came to be a part of the credential information.
Mm-hmm. I was going to mention that specifically. So yes, the pod that reads the credential, the workload that reads the credential, pretty much. I know this about the AWS S3 clients. They have a concept of expiry. So if we were to present, an expiry time, the workload can be ready for the expiry to happen. In general, though, AWS clients um, do the refresh themselves.
Mm-hmm.
Now, in our case, we'll be asking, we'll be doing it for it.
Well, it should do it as well, right? We need the SDK to reload the file, basically, as well.
Well, I mean, what I'm trying to say is, okay, so I need to look this up. So whoever has the credentials basically is authenticated as that user, and they by default have permissions to refresh it. Or that's
With which API?
With S3. Okay, so you're saying they won't have access to the credentials API.
Well, depending if it's an IAM API, for example.
They won't have access, yes.
Right.
But
I mean, we can include an IAM API, but then it's kind of out of the scope of what we're trying to achieve here in terms of providing REST APIs for that, right? But I just think that.
What do you mean by providing an IAM API?
No, we're saying it's a bad idea. So yeah, we're coming up with, we were just talking about how clients themselves, whoever is accessing the data, can actually go ahead and refresh the tokens that they have. But in order to make that happen, they'll need access to the IAM API, to the backend IAM API, and short of that, what we can do is we can provide an IAM API that they can call. But if you were to go down that route, you're actually providing things that you shouldn't be. It'll become technical debt very soon if we go down that road. So that's what we were talking about.
And I think we do have, credential minting in that, like in Cozy, it's already there, right? And the missing piece or the missing link here is the refresh. And I think each component, because we have like these components stacked together, each component knows exactly how to refresh from the one that provided to him, right? So the pod will just need to refresh from a file. That's pretty clear. When the expiry hits, whatever I need to do is just start refreshing until I get something which is valid for longer, or maybe have that. It doesn't have to be stupid, but I'm just saying it needs to start that task. It needs to understand that it needs to wake up at some point in time, which is the expiry time, and from that point to attempt to refresh. And same thing for the node adapter, and same thing for the controller, which will set the BA set this in the BA, and will ask from the sidecar this information, and same for the sidecar maybe. So it can be really something that if it's part of the information, it's pretty easy to understand. And then the last question, or the first question I asked, was how much are we assuming, how much can we assume that an expiry time, which is like a wall clock, right, with something, you cannot use a duration, because duration doesn't mean anything for expiry. You have to put some wall clock there. So the question is, can this work in Kubernetes environments? And I'm not too knowledgeable about how much is Kubernetes assuming, at least that it's not completely off sync, right?
Why can't you just set a duration? What's the rationale for that?
Because let's assume you put a duration on it, then what does it mean for somebody reading the credentials when to refresh? You can say that the duration is the refresh duration, but then like say that I've put a year for just for the sake of the example, then what does it mean? I need to refresh once a year? Is that
well, I'll put it a different way. Let's say it's 60 minutes or 1 hour. then let's say the controller goes down and comes back up. The controller could have come back up, after 60 minutes, before 60 minutes, you wouldn't know. But when it goes and reads the file, or when it goes and reads the resource, it's still going to see 60 minutes. So duration is not, there's no way to make that happen. Like understand what it is the expiry time is.
So just for information, most of the APIs today to specify expiration is the duration.
Yeah, but that's because that's in the spec. What we're saying there is this is the amount of time we want this API or whatever you're creating to be valid. But we are talking about a status. But you're making me think about this. Should we make it a spec field where we say this BA has to be, has to have a refresh duration of so long? And then based on
that duration spec for sure, and then you need to somehow stabilize it in a status for some way, right? To say, okay, so once these credentials were minted, the expiry plus the duration, the validity duration is, that's the time. And now every component, whatever whenever it restarts or whatever, when it reads it, knows exactly when to expect the expiry.
So I know this so let me pull up some code. I know that time-based things are done in Kubernetes, especially in checking how if a node went down or not. So let's see. I remember in the node controller we had this. So what it does is it waits for node resync period. I think that's like 30 seconds or something, or maybe 1 minute. And if
one minute.
If 3 times the resync period amount of time there's no updates from the node, then we assume that the node has gone down. So I want to look into how they take care of time there. So node lifecycle. Node lifecycle controller. Here there is a type where the controller starts. Where's the new controller call? There it is. Okay.
Is this a controller? Is this like running as a single controller there?
It's a part of the core controller manager.
Right, but then so just to I think there's maybe an easy way in this case, because if it's a single controller, it's less likely to to pass this time around between nodes, right?
Can you repeat that?
Yeah, I'm just saying, like if I run just one controller and I'm setting the time for myself, right, so that I can take a look at this later on. It's not that it's not possible that I move between nodes and expose myself to a problem, clock problem, but I think it's less likely compared to what I was describing, which means there's already multiple components involved, which might be distributed across nodes. Do you see what I'm saying?
Yeah, I see what you're saying. Yes. So
I'm not saying it necessarily makes the argument not enough for claiming that.
I see what you mean. So I'll tell you what I'm looking for here. I'm looking for assumptions that they've made in this code. Basically, what I'm looking for is they check the last updated timestamp on the node object, and then they check that with the current time.
I see. Okay.
So that's what I'm looking for. So if they've made that assumption, if there is assumptions like that already in Kubernetes, assuming that the clocks are reasonably in sync, maybe I think the allowed amount of drift is 1 minute, I don't know, 2 seconds, I don't know, for TLS. So if there is an assumption here that the clocks are in sync, then we should be okay. We should be able to make that assumption too.
And our use case is not about having very, very strict timing, right? It's mainly about just having rotation aware or refresh aware times. Yeah.
Right.
So what about not managing time? at all, and just refreshing when something. So, for instance, there is a credential error, and we force a refresh. So basically, we force minting a new token.
So how do you communicate that to the pod? That's a question. You can do it with pod like container notifier or other things, but
to be honest, most of the applications, they are not token aware. They are not, they don't manage actively the refresh of the tokens. I mean, some applications do, but it's very rare.
Okay, so this is interesting. So
is it better to have, for instance, the pod crashing and restarting and reminting?
So we did discuss that restarting pods would make sense for revoking access, something which doesn't fit into the rotation use case, because the rotation, which is more of a planned activity, at least in terms of design, not in terms of reality. So like you say, it might be that to begin with, many of the applications do not support this to to even reload. Whatever we do on top will not help, right? But on the other hand, if we are trying to even provide a rotation mechanism, then restarting pods on every rotation event was discouraged a little bit, at least in previous discussions.
Okay, so here's one more thing. So what node controller does is it doesn't check for current time versus last observed time. It rather has an in-process data structure of the current list of nodes, and it refreshes this every node monitor period. And then it checks if it wasn't able to reach it for 3 different periods in succession. So maybe we can do something like this too, where we have a access monitor period or something, and we periodically check. We can even call the driver to periodically check, hey, is this still valid? And we don't have to do any timing things.
So that's like a tick, right? You're suggesting like creating a tick, something ticking in that system.
So the difference between nodes and access is that we'll likely have more accesses than nodes, so it can quickly become a scaling challenge, right?
Yeah, I guess. Yeah.
So going back to the, do you know what's the use case for Cozy, and what are the apps which are going to use Cozy? I mean, do you have an idea?
Well,
object storage applications, you mean?
Yeah, but will it be, I don't know, people doing
I don't think it's really easy to classify this as one type of use case.
Yeah, we're feeling like a platform kind of thing. But I'll tell you what are the most common use cases for Munayo customers. Many of them, or the majority of it is big data workloads. And these workloads, the way they look like is, for each workload, they have a central large data store, say S3 or Minai or whatever, and each team does one part of the data management lifecycle. Either they're bringing in data, transforming it, or querying it, or whatever. And each team gets their own access to the data or portions of the data. So like say specific buckets. So you could reasonably say for every microservice that one team runs, and things are moving to a microservice architecture there also. For every microservice that one team runs, they're going to have a particular access credential for it.
Okay, and they are the data, the chief data officer or whatever. Probably they would want the token to be short-lived, like maybe, I don't know, 1 day or 1 week or 1 month. But generally, it's not open bar. I mean, you cannot just.
Are you saying that by default there's no expiry? Is that what you're saying?
No. I'm saying the opposite.
Oh, okay.
So generally, so the people in charge of security, they don't like permanent credentials.
Right.
Like they don't like giving a key forever.
Mm-hmm.
And in worst case, they will delete the key. So, for instance, if they see a key sticking around for like 6 months,
that's true. Mm-hmm.
they will delete it. So the goal is to provide the mechanism to preemptively say it's okay. You can specify you need the key for 1 month, so you get the key for 1 month, or 1 day or 2 days. I don't think it's supposed to be. I mean, I don't think it's practical if you ask a key for.
I see.
1 minute.
Mm-hmm.
I mean,
oh no, yeah, I see what you mean. So yeah, I see what you mean. You're saying it's kind of ridiculous to constantly check if the key is active or not, right?
Kind of.
Yeah, I see what you mean. Yeah, no, that's fair. That's totally fair. I think we were also saying the same thing. That's one reason, because it's very unlikely that you need to constantly check if it's valid or not, and it's probably very expensive also. That's the part we were getting to. Tell me.
Yeah, no, okay.
Yeah.
So it should ideally it's a work session. The work is, I think, it's will be 1 day. So, but typically for big data workloads, when you start a project, it's 1 month, 1 week.
Yeah, something like that. So that brings me to another thing. Yes, with tokens, we run the risk of leaking them. It is not really the most secure method. We could say tokens, they don't come with credential rotation, and there is other risks associated with using actual tokens, and we could say they should only use IAM if they want more security, because if you're using IAM, where a service account associated with the pod, it is given access to object storage. In that case, there's no token, so nothing can be leaked, and we don't have we can enforce rotation much more easily. That might be, and you don't really need rotation at that point.
Yeah, but my point is there is no way in a production environment somebody is giving away a static key. So I'm thinking,
right, exactly.
You have 2 types of keys, right? In the object storage world, you have the static keys. So, for instance, on Amazon, it's the access key, secret key pair, and you have the dynamic keys, so that they invented afterwards due to security issues. It's basically access key, secret key, and token, right? Since we are minting credentials, so basically we are generating keys. Generally, the trend is that static keys, they disappear, right? So there is we still need them for some apps and all, but we are going towards a model where
exactly
it's only STS keys.
Yes. Well, STS also, STS is a little more restrictive. STS stands for single or simple token service in Amazon. What it gives you is a single token that you can use with very specific types of credentials.
So but that's the problem of the driver. So for instance, I can totally return you an STS token, so a triplet, access key, secret key, STS, bound to a role, so there is no actual identity behind. It's just temporary access, and that's actually what I want to do, because I don't want to give you full access. So the first point is the trend of giving full access, like static keys, is disappearing in the industry.
Yeah.
Second, if you're minting dynamically credentials, basically it's a program, automated program delivering credentials to another program, then it has to be temporary, right? It cannot be.
Agreed.
Yeah. So in the back, for sure, the driver providers, they will probably deliver temporary credentials anyways, right?
So let me ask you this. Is it possible to I'm not sure about this. Is it possible to create tokens, that is access key and secret key, with an expiry?
No. So for instance, in our driver, we are going to mint temporary credentials. So we will return a triplet access key, secret key, STS, part of the credentials blob, which will be mounted in the pod. And the pod has to basically read the triplet and
right. No, I understand that part, but let me ask you just more generically, without Cozy in mind. Let's take Amazon. Can you create access key and secret key in Amazon for a particular identity, such that the access key and secret key have an expiry on them?
No, you have to create an STS token.
That's the only way.
Yeah.
Understood. Okay. So that's a really good point you've brought up. Then that changes a lot of things.
I don't think it changes a lot of things. I mean,
no,
practically people will deliver temporary tokens.
Right. I'll tell you what I mean. Yeah.
So the thing is, pods will fail. The credential will be expired, and will crash, and the application will stop. That will happen.
Yeah.
So we simply find a way to I don't know, to refresh.
I still think, okay, so I'll tell you why I said a lot of things changes, because it brings me back to this whole idea of we shouldn't be doing any credential rotation for access key, secret key style of access. Because just like you said, there are multiple problems associated with it. One is, let's say we mint new tokens. We come up with this concept of expiry where we go and manually delete them, or with the automated controller, we go and delete the keys after the expiry. The problem there is, you have to coordinate the deletion and the creation of new keys to run together. Now, let's say you create the new keys first and then delete them. In that case, you end up creating the new keys, and there is a possibility that the controller goes down right after you create them. So the new pod, the pod can use the new credentials, but the old credentials are not gone yet. Like you're saying, they stick around and it's leaking.
Hey, Sid, I don't think we should try to implement credential rotation in Cozy.
Exactly. I was trying to say.
Yeah. But if a Cozy driver wants to do it inside the driver, or if a storage system wants to do it inside the storage system, Cozy should not prevent it from happening. That's how I look at it.
Yeah.
Because
correct. But
it may already be. I mean, some storage systems might automatically just expire tokens after a certain amount of time, and so there needs to be a facility to deal with that.
I see. All right, so let's do this. I think one of the things that I'm missing is what are the different styles of access for? Just take the major object storage vendors. Let's take Microsoft, Google, and Amazon, S3, and we'll do some background research and understand how they do expiry and rotation. And let's continue the conversation on Monday. Because when Vianney just brought this up, it's pretty clear to me that AWS S3, at least, if you're doing access keys and secret keys, you can't expire them. You'll have to, let's say you rely on the driver to do it, then you still have to come up with a mechanism to coordinate with the driver on that expiry thing.
I would say a simple refresh command would be fine.
So when do you call the refresh command? So you're saying we'll call the refresh command?
But
what you would need at a minimum would be when you mint a credential through the Cozy RPC, the driver should be able to return a call me back by date,
Mm-hmm.
like a refresh date.
Mm-hmm.
And then there would be an expectation that the sidecar would check,
Mm-hmm.
around that time,
Mm-hmm.
did the credential change? And then if it did, there's got to be some way to obtain the new one
Mm-hmm.
and, somehow propagate it to the consumers of it, so that if a pod outlives the actual expiration date of so you imagine you have a token good for 30 days. At around 20 days, it's time to refresh it.
Mm-hmm.
So, it can be fuzzy, but if you don't do it and the pod lives 10 more days,
Mm-hmm.
eventually the pod's going to get access denied. So at some point you want to give them the new credential, but like a driver could say, you know what, my credential is good forever, or every time you do a refresh, it could just give you back the same key and say, nope, it didn't change. Nope, it didn't change. And that could be
how
the
do we
default.
make it idempotent? That's my concern. Like what can happen is, right after I call refresh, let's say the driver has actually gone and created the new tokens, the whole thing can come down.
Come down how?
Let's say the node failed, where the driver and sidecar are running.
Yeah, well, you would have some state tracking on whether you had refreshed this particular bucket access.
Yeah, you're expecting the driver to do that now.
There's some sidecar that is watching all the bucket accesses, and they could all have some expiration dates or refresh dates, and then every time you have some controller that just watches them, and then when you get to the expiration date, you go do the refresh, and then once the refresh is done, you update another timestamp saying, I did the refresh.
Mm-hmm.
And then if anything goes wrong in the middle, you just, next time the controller comes up, it'll start work at the top of its queue and get back to that one, because it's not marked as being done yet.
The whole point of using tokens with expiration is that you don't care if you leak tokens, because they will expire. So you don't have really to manage.
And I like the idea of not trying to implement anything fancy in Cozy and say, look, Cozy doesn't know what's going on below. Cozy's just going to, ask the driver to give it the most up-to-date value for a given access token, and with the understanding that it might change over time.
So one use case would be, for instance, I got a deployment and let's say a project for one month, and I need a key for 1 month. So then you get the key, the driver will expire the key, in 1 month, and you can work. And after 1 month, if somebody tries to run the job or whatever, to do whatever, to run the project, it will fail because the credentials will be expired, and that's fine, because in the initial specification of the project, it was supposed to last 1 month, and then what you do is you change, so you restart the whole deployment. You ask another key and all. But so that for sure, that's will be most of the use cases. But there will be also some use cases where, for some reason, you don't want to trash the whole thing. You want to keep for some reason you want to extend the duration of the project. Project was supposed to be 1 month, and you have all the data in place and all, and you need to have 1 more month to finish. So in this case, it would be interesting to refresh the token, the existing credentials.
Yeah, I think we all kind of just assume that automated refresh, without downtime is important.
But that's not exactly what I was saying. I was saying.
It can be done with Cozy getting out of the way, right? It doesn't have to make Cozy more complicated. Cozy just needs a facility to discover that the key has changed and to propagate that to all the pods that need it.
I think it might be interesting to automatically refresh, if somebody wants to refresh the credentials, then they are propagated back to the pod without any disruption, like without any pod restart.
Okay, got it. Okay, yeah, I think that's what I was trying to say too. There should be a mechanism for that. Okay, so
and that's actually the hard part, is that mechanism. Like, all of the details around actual queue rotation can be pushed down below Cozy into the driver and say, you know what, you figure out when to do it and how to do it and where to do it, and we'll just periodically ask you if it's been done.
Hey, sorry, time check.
Yeah, we're out of time. Let's continue on Monday. It's getting more interesting. This is good. In the meantime, what I'll do, or if you also can do some research on this, that'll be good. We'll go look into the major cloud providers and your own object storage systems to see what kind of access mechanisms you have and what kind of expiry mechanisms you have.
And Sid, real quick, I don't know if anyone mentioned this at the beginning of the meeting because I was late, but I wanted to mention to you that like every other week, the Kubernetes storage SIG has a meeting immediately before this one.
Mm-hmm.
And nobody from this group shows up to that meeting to give status on Cozy. So I usually give some sort of inaccurate status. So
Okay.
it would be good to have someone show up to those meetings, or if you want to tell me what to tell them.
Mm-hmm.
Srini used to be there, but then I don't know if he's still involved in this project.
He's still involved. He's just he just changed jobs.
Okay.
So he's been a little busy lately. But yes, so Ben, I'm happy to join as well. But if not, yeah, I'll talk to you. I'll let you know whatever you need to give it. Is that on Thursdays or is that you? Do you mean on
Right before this meeting?
Every other Thursday, right before this meeting.
Okay. All right. Okay. Yeah. If I can't make it, I'll let you know. And if not, I myself will come and give an update.
That's cool.
All right. Thanks for letting us know, Ben.
So I think today I only recorded half of the meeting. I only remembered in the middle of the meeting.
It's okay. Yeah.
Okay. Thank you.
All right. Let's
Thank
all
you.
meet on Monday. Thank you, everyone.
Bye.
Bye.